Welcome, everybody.
Welcome back, everyone. This will be the last session of the Power Electronics event. Over the past 3 days, we had over 500 viewers in 16 different sessions. The last session for the event will be a presentation from Oliver Opitz from Würth Elektronik, and he will talk us through his presentation about the emotional intelligence in the Formula E. Just a little message beforehand. If you click on the little screen, you can put it into your full screen. Well, Oliver, it's up to you. The digital stage is yours. Good luck.
Thank you, Melvin. Welcome, everybody. As Melvin said, I got the opportunity to close down the whole Power Electronics Forum. I'm not putting any pressure on me, but actually he did. But I hope I can serve it. So once again, I'm happy to be part of it, to show you something about our close cooperation we have with Audi Sport. And at this point, just a quick introduction of who we are and what we do. I'm probably sure that most of you already know Würth Elektronik. You probably have attended one or the other 2 sessions of Würth Elektronik Netherlands from our FAEs. Nevertheless, to give you a quick overview, we are a manufacturer and sales company of electronic and electromechanical components. You can see here a quick overview of our products. So we are actually having or offering quite a bunch of components, a big portfolio, starting with the LEDs, from signal LEDs to power lighting LEDs. We are in the field of power modules, meaning other people might heard about power ICs. So we are integrating an IC combined with passive components. We are in the field of wireless connectivity and sensors, where we offer a big range of cable replacement modules, GNSS modules, as well as different kind of sensors. A certain portfolio of connectors, board-to-board, wire-to-board, cables, fuse holders, some kind of, I would say, components on the side, a lot of switches, rotary switches, dip switches. We even offer the shrinking tubes, which fulfills more or less the portfolio. A quite interesting component is the so-called red cube. Other people might heard about the PressFit technology, which is a very interesting product, especially for the electric vehicle, to bring power to the board and from the board. We actually come from EMC components and power inductors, so the typical clamp-on ferrite power or common mode chokes, and EMC shieldings, capacitors, and all kind of varieties, SMD, THD, the same for the power inductors, power magnetics itself, the filter inductors, power inductors, especially for switch mode power supplies, all typical different power ranges from very low currents in the milliamps up to hundreds of amps. And last but not least, we are into signal and communication, discrete and integrated LAN transformers, regular power transformers, LTCC components, and RF inductors. But that's it mainly about the company. I would say from this point, already in the beginning, I usually switch that slide to the beginning and not to the end. I would already say thank you for the attention, listening to me, and signing up for the session. As Melvin said, my name is Oliver Opitz. If we do not have enough time at the end to answer all questions, to address all the topics, feel free to shoot me an email, and I will try to respond as soon as possible. Usually, we are service leader, and we try to answer within 24 hours. I'm now 13 years with the company. I'm power engineer by myself. Used to be, I'm now, of course, more and more into management, but I used to live a couple of years in the US, in Silicon Valley, and was working with the main IC manufacturers to develop reference designs to bring the latest and greatest technologies and power magnetics to their evaluation boards, and finally then to make standard products out of it for our customers. Topic today is emotional intelligence. You might wonder what What is emotional intelligence? I'm pretty sure you have heard about the intelligence quotient, what engineers are quite aware of. But the emotional intelligence or the emotional intelligence factor is not really focused on. For us, especially for power management engineers as we are, it's quite important to know about something like this, as there is no application out there in the world, and you're aware of it, which works without power. As soon as electronics are involved, you need some kind of power management. Unfortunately, there are a lot of people out there who do not even care about power. It's not their main business, especially if we are moving into software and device integration. But in our heart, there is some kind of blood which brings the passion for power. And that's why, for us, the question is really, what does emotional intelligence even has to do with power electronics? And therefore, I would even like to tell you a quick story about why did Würth Elektronik sign up and got into a partnership with Audi Sport, together with Abt Sportsline and together with Schaeffler, because for us it's a kind of an accessible field for all the engineers. For us, it's quite important to picture the highest quality and the most reliable components at the end, running lap by lap around the track. And we want to get into our company talents, especially from the field of engineering, to show the difference. For us, it's always quite easy to understand what's inside, but for the public, it's quite difficult to see. To give you one or two examples, is here you see on the right side a headlight from an Audi A7. It's quite obvious and visible to the outside. So if you either are part of the company who was developing a car, or in this case a rear light, it's some kind of proudness what you have if you pass by a car, if you drive that car by yourself, or you open up your garage door and you see that headlight or a rear light, and you have been part of that development, either on the outside or even on the electronic development. And for us, on the left side, you see a kind of a quick overview of some power inductors. How do we tell our engineers already in the interviewing process when they apply for a job with us? Or how do we even tell our customers the things we do are sexy? Talking with the eyes of an engineer, it's quite difficult. And this brings us the partnership with Audi Sports on one hand, that we finally got pictures on what applications are we actually into. To give you another example, talking about the electric drivetrain, on the right you see the very complex electric drivetrain with all its different components and facets. And now the question is for our engineers, okay, what do we do? What kind of advantage do we bring to the automotive manufacturer, to the development team, that makes me as an engineer proud that I was able to help to design and make it workable? And you see on the left side the so-called press-fit power elements. And there is quite some technique into it. It's not just a piece of steel. We're talking about the galvanization, we talk about a certain current distribution in the power element, and bringing that into such an engine, and you will see later what we could make on improvement through Formula E, makes it more sexy for our engineers, makes it more sexy for us, because finally our engineers know where do our applications get into. We at Würth Elektronik, we are usually not serving the bigger companies, typically in the consumer field. We are focused on small and medium-sized customers, and that's why our products at the end, they go into thousands of different applications. And now bringing from the sales field the feedback back to the engineers and tell them or give them an overview about all these applications and tell them this is where your product was designed into is quite difficult. And here we have the chance with Formula E, and especially with the cooperation of Audi Sports, to get finally pictures for it. You might recognize that Of course, passive and electromechanical components, they might not be as sexy on the first view, but you as power engineers, I'm 100% sure you know they are at least as crucial as anything else in power electronics. I would like to give you a quick heads up on why did Würth Elektronik not start already 20, 25 years ago when the company was founded on working with the automotive manufacturer with the gasoline engines, meaning internal combustion engines. We did in a certain field of filtering, so we are actually the biggest manufacturer of so-called rod core chokes. You know, there's this kind of copper spring with a ferrite core in it, but the internal combustion engine does not have as many electronic components in it as it will be in the future with electrical vehicles. And you see here, a friend of mine, you will see on this and on the next slide, shared this overview with me. So thanks all if you're part of it. That in 2015, you know, a couple of years back, 5 years back, when we did not think even about a situation like COVID-19, the distribution was quite clear. There were 98% of gasoline engines and 2% only of electrical vehicles. But the next step already this year in 2020, I don't want to name any manufacturer, but you know probably some of them, and one of them in sunny California, the German ones are coming step by step into that market. The share starts to differentiate so that we only have 88% in internal combustion engines and 11% in electrical vehicles. I don't know if the chat is open. I would even ask, what do you think? Do you have any idea what it could be in 2025? Any numbers you want to throw into the presentation? Unless Niels tells me that the public chat is closed. Okay, the public chat is open. So any guess what the share will be of internal combustion engines versus electrical vehicles in 2025? Any idea? Feel free to come up with a number. I would look forward to it. You know, usually it's easier when we're sitting together in a face-to-face event, but let's make the best out of it. We have here a great setup from Mark and his team with Webinar Geek. I really love it. I used to do other webinars the last couple of weeks, but here numbers come in 20%, 30%, 50%. Okay, let me open the number. 27 plus 7, 34%. So it's already good. Thank you for sharing the numbers. 45, 25%, 35. Tony said it's 35%. I'm not naming the last name because of the GDPR I was highlighted to. But Tony was very close, 35%. Usually I would throw gummy bears from our company, but we don't have them. So in 2030, it will finally flip over that we have more electrical vehicles on the road than internal combustion engines. Of course, this is a prediction, but nevertheless, you see that the share starts to totally flip over to electrical vehicles, and there is a need for it. The need comes because the European Union, with their CO2 emission standards, they make it quite difficult for our car manufacturers around the globe to fulfill these emission standards. The fumes to emit at the end to the environment, in 2015, it was 130 grams per kilometer. In 2021, we end up at 95. So we almost dropped down 40%. In 2025, the car manufacturers will only be able to fulfill these emission standards if they start selling electrical vehicles. It comes with all that green environment and change of climate change. I think from my point of view, if I put value in it, it's the right way to do it. The electrical engine has been there before the internal combustion engine. Of course, there are challenges to face. We have to face, but we all work together on it. And even in 2030, we dropped down to 59 grams per kilometers. So how are they able to fulfill that CO2 emissions? Quite simply, just by bringing electrical vehicles to it. And this is where the numbers come from. As you have seen here, by 2030s, we need a lot of electrical vehicles on it. And you see that the transition requires more and more power electronics, which at the end means this requires more and more passive and electromechanical components. And this is very important for us as Würth Elektronik to bring our components into that business and applications. Down the road, there are always other challenges we have to face as well. Okay, let me just quickly, there's the question of EVs and also hybrid. Okay, there was a question, what's the difference between EV and BEV? Niels already explained it, battery vehicle, electric vehicle, and of course then the PHV is the, let me go back to that slide, I just have to flip over. The question was, what are the EVs and BEVs? On the bottom you can see electrical vehicles means also hybrids are included, and the battery, pure battery electrical driven vehicles. So Niels, thanks for answering the questions. I was heading to another slide talking about the shift from silicon to silicon carbide. Why is that important? Because we are ending up of miniaturization, of more power efficiency, because the more efficient the power supply is, I don't need to tell you, the more juice from the battery we can use to bring it down the road. And a friend of mine, Ole Gergensmeyer, who's responsible for the whole sales in Europe from Cree, they were doing kind of a questionnaire with their customers. And in 2017, they were asking, do you plan to use silicon carbide? And most of them said in 2015, no. In 2018, the picture already changed significantly. What was not expected, that almost half said yes, and another third said probably. So there was only a very, very low minority saying there will be no shift. And in 2019, speaking of last year, 2/3 already said they will change to silicon carbide. The reason why they do that is because there's a real big difference talking about the losses between silicon and silicon carbide. If you compare here on a 400-volt system, the total inverter losses, and you take the baseline of, on the left side, the green baseline of 100% as the silicon regular device, as you might know it since years, and compare that to the silicon carbide with a certain switching frequency, you can see that the losses, they drop significantly. We end up at 29%, or at 400 amps, even still at about 50%. If we look into even higher voltages, this becomes more and more interesting with all the fast charging technologies, what the car manufacturers want to introduce to be able to charge your car. If you are on a long-term trip with your family, you don't have time to charge your car for 6 hours, take a stop or stay overnight. You want to recharge your car as you're used to with a gasoline engine, stop, plug it in, and charge within 15 or 20 minutes. And here on 800-volt systems, the losses are still very, very low. So the silicon carbide MOSFETs, they really offer significant lower losses in comparison to the silicon IGBTs. And this on 400 as well as on 800 volts. The thing is that what a lot of people do not really want to hear is that we need to reduce losses not only in the active side, on the active component side, we need to reduce the losses as well in passive and electromechanical components as well. And to give you a quick overview of an example of an inductor, the total inductor losses, they consist out of core losses and of copper losses. I'm pretty sure most of you might have known about it, but it helps to give you a quick overview. The core losses are hysteresis losses and eddy current losses. They are frequency dependent losses in the core. Copper is not just DCR. Now with increasing frequencies, we have to consider the AC losses, talking about skin effect and talking about proximity effect, meaning you know, the higher the frequency, it's kind of like increasing the DC resistance. I mean, this is, for us, it's quite interesting since many, many years on the low power switch mode power supplies, where the miniaturization was taking place or coming from the consumer business, because we as consumers pushed our manufacturers of mobile phones. Don't want to mention names, but the one from Cupertino or another one from South Korea or even from China. We wanted to have our consumer smartphones, mobile devices, we wanted to have them as thin as possible, as small as possible. Even we wanted to have the biggest screen. So when I was back in the US in 2009, we had to make really, really thin power inductors for the 0.6, 0.8 millimeters and bringing still 2 to 3 amps on it. And the way to make them smaller and was only to increase frequency. And this is what we now recognize in the automotive world as well, that the frequencies are growing to make things smaller. The bottom line, what you maybe should remember from the last couple of 2-3 slides is, if the frequency goes up, the losses go up. I mean, if the losses go up, there is one solution, which makes it quite easy, but we need to dig deeper into it, which means, or let's raise the question, with decreasing losses, can we sacrifice size? That's what I just said. There's a simple solution to decrease losses by just make the parts bigger. Of course not. This is not where we are heading to. And if you look into the motorsport, not just Formula E, you will recognize this is the top-notch technology where the car manufacturers spend probably a little bit more money into it because it's about reliability as well. We need to figure out a way to make everything smaller and to make everything lightweighter. So the size and weight of passive and electromechanical components, they have to be lowered. There is no question how or what or why. It's simply the fact we have to make it smaller. We have to make it more lightweight. To give you 2 examples to that, I brought here once again the so-called PressFit, which is running up to 500 amps on a number of certain pins. Here you can, what you cannot see, but you probably might be able to count it. You have 16 pins on the bottom with a certain power and current distribution. And one of it is in a weight of 28 grams. 28 grams is not much if you compare it to a car weight of 1.5 tons or even more. But if in the car you probably have up to 50 of these press fits and you ended up, you sum it up, you accumulate it, there is some weight which comes together. So what we did is we dig deeper into the so-called 3D printing technologies, and we printed that in the future for or with different materials. They are not ready for mass production yet. We are testing them in our labs together with Audi Sports to bring them probably at some point into the race car, but they are undergoing a lot of tests right now because it's really as new. But as you can see, best case running from 28 grams to 6 grams, we could really lower the weight, but by keeping the current distribution and keeping the power being able to run through a power element. Still with steel, we have half of it, and with copper, it's almost half of the weight. And this is quite interesting technology we are considering right now, and where we are going to look closer into it. How can we do that into mass production? The second example is we're talking about a power supply size reduction. So on the left side, you see a regular silicon MOSFET gate driver in a certain size, 1120 square millimeters. The weight was 12.4 grams, capacitance 14 picofarads, and an efficiency of almost 80%, which was actually not that bad. But our target was to make it smaller and even higher efficiency. So we came up with a design with a way different winding technology within the transformer. We moved from a planar design to a regular winding design using different Litz wires, using silicon carbide, or being prepared for silicon carbide MOSFET drivers. So the frequency was going up, and we could bring the weight down to 25%. The size was decreased by 65%, capacitance by half, and on top of that, the efficiency was even going up. Oh, my math is wrong. 79 to 86 is not 9%, it's 7%. Apologize. So we could even in this example show that we can make things from a couple of years back way smaller, but way more efficient. And this is, I guess, where I'm pretty sure where you come into play as power electronics engineer. This is what you're working on. But now bringing these components into a car to make it really visible for our engineers, that they can be proud of where this is ending up and winning races, you know, being on the podium and cheering and celebrating with the team and having customers at the racetrack. This is what brings the proudness and the so-called emotional intelligence finally into our house. Before I keep going, is there any question in between? Because I'm talking a lot, and I try to, I really enjoy usually the face-to-face meetings where I can see how you react, and hope not you're falling into sleep. If there's any question in between, please feel free to go to the public chat and raise your questions. Either I will respond in parallel, or Niels will be able to help as well. The bottom line for us, then the question comes up, where do we find passive and electromechanical components, especially with the focus of electrical vehicles? We can quickly summarize it in, of course, a DC-DC converter, then an AC-DC converter or a DC-AC converter. Okay, I guess there was a question coming in. No, there have been no questions, and then it was just a reminder from Melvin. Melvin, thank you. Coming back, AC to DC or DC to AC converter, this is just another word for the inverter. So either it's from the battery to the electrical engine, coming from a DC current to a three-phase AC current, or during the recuperation phase that we bring the AC current from the electrical generator in that case. So we switch the electrical engine into an electrical generator and recharge the battery. Power factor correction, very, very important for high currents and high voltages. And not to forget that passive components are used quite a lot for isolation barriers. To name these kind of application types, what I was mentioning before, we are ending up in fast chargers for electrical vehicles. Since many, many years around, we have the inverters for solar power. High efficiency power data centers, quite an important topic, you know, with the IoT. I'm not that old yet, but when I first got in touch with data centers, we still called it machine to machine. Today, everything is called IoT as soon as you connect it to the internet. There's more data going into data centers, cloud computing. And I remember when I was working back then with a company who was providing some searching functions and a very well-known website, and they have their own data centers. We were working on increases of efficiency of just 0.2% or 0.3% per year, because the amount of power they pull from the grid to bring it to their power data centers, it is pure money what they save. And of course, as I just said, the low power auxiliary switchable power supplies. To show you a clear example here, on the left side, you see the electrical engine, which has built in the little, here in the picture, the little inverter. You can see the capacitors, the black banks, and all the way on the bottom, the customized PressFit power elements. They have been very low profile, but keeping the high current capability. The capacitors was very, very difficult for us to make them smaller, but keep the isolation between the different layers. And we were able to do it. And at the end, 3-4 years later, the knowledge, I need to say not our components, but the knowledge during the development ended up in an inverter from the Audi e-tron. So this is how the collaboration from the racetrack, where we spend more, let's say, resources into, because we want to win, we want to bring the title back home, and at the end to develop really the latest, greatest technology for our customers and bring it into our catalog as a standard component. It ended up in a serial production of a new coming car for the road. In the Formula E car, I would like to give you an overview of the relevant electronic systems we are working on together with the team, especially with the development team, which is on the one side the brake-by-wire system and the controlling unit, meaning the brake-by-wire system is not like you might remember from the past to have some hydraulic system from the pedal to the brake directly. There's an electrical system in between, and here it's not about, in this case, about power efficiency immediately. First of all, it's about security and safety, meaning reliability. The system has to work at any time, under any circumstances, and there we need to bring really components to the field which will not fail during races. We have the powertrain cooling system, because it's very important that you need to cool the battery all the times, otherwise first the battery will start to degrade the power output, which means in this case you're becoming slower and slower on the road, on the track, and at the end it even will switch down. If you did follow the Formula E from the first 2 seasons, you might have seen that cars were stuck on the side and they had to reboot and reset. So they just stopped on the side, stand there for 20-30 seconds and had to reboot the system, was because the cooling system was switching off the battery, which simply could happen because of a defect in the temperature sensor. So you just switched off the car, rebooted the computer, the temperature sensor was working again, and you could keep racing. And last but not least, of course, in the back of the car, there's the MGU, the inverter, DC to AC converter, as well as AC to DC converter. A lot of DC-DC converters, so meaning in general all the power electronics. But that's not just it. If you look into or onto the steering wheel, it's not just a simple steering wheel anymore. I'm pretty sure you just need to look into your own car, how many buttons you have, and probably already displays. You need LED drivers for the LEDs. You need the switching power supplies to power the LED, the LCD display, or the whole steering wheel in general, to be able to control and work on all the processes with the microcontrollers. So the microcontrollers, they need power. And at the end, the steering wheel is also quite a good antenna to catch all the field from the outside and bring it back into the car. That's the worst scenario. So we need a lot of EMC fielders in there. And at the end, you don't want to have a steering wheel which is either quite big, like a truck or a coach, a bus steering wheel. You still want to have it small and, of course, lightweight. And last but not least, here once again the rear light. You see on the left side the rear light from a Formula E car, and on the right side from the Audi A8. Here we need the LED drivers, quite clear. So bottom line, not to forget, everything we work on needs to be based as well on high quality and high reliability. This is really what matters, because we cannot foresee the customer's environment, especially as power electronic engineers. You know, we provide a service to other engineers who make out of that power electronics or power management, or by using the power management, a total device, a final device. But what that might be, or where this is going to end up, in most of the cases we do not know. But that's why for us as Würth Electronics, the quality and reliability is part of it from the beginning, from the first scratch. And this is where it totally fits together with the Formula E team from Audi Sport. Once again, remember, where can we find passive and electromechanical components? I would like to finalize then the presentation. If you look into a current source of an LED driver here on a demo board from us, there is the inductor, can be either the power inductor or filter inductor. You have the capacitors that might be the EMI capacitors or the capacitors simply just to filter the signals coming from the outside. You have an integrated power module, and last but not least, the resistors on board. And not to forget, there are a lot of bunch of simple parts on it, like connectors, test pins, switches. But even with these side components, like test pins or PCB spacers, it's quite important to keep the quality high with everything. It's not just one certain component which needs to have the highest quality. It's kind of a chain, and there's supposed to be no weak link into the chain. So conclusion, finalize then the presentation is emotional intelligence means for us the public will see the outline, you will see the car, your customers will see the car, your wife, your kids, or your husband will see the car, the nice shiny outside of the device. But for us, it's important that you as an engineer feel proud of what you're doing and bring that to the table and say, hey, I'm part of the outline. So thank you very much. We have still 8-9 minutes left for questions, so feel free to answer questions, to ask questions, and we will be happy to answer them. So right now there is no question coming in. Melvin was highlighting even in the chat that we are looking into some questions. I hope everybody is still awake and not falling asleep. It's at some point quite difficult to follow a presentation if someone is making it a monologue. I know how this is sometimes, but yeah, as Niels just said, I hope everybody is typing. Maybe the server is down because we cannot fulfill all the questions coming in. So there are two options, ladies and gentlemen. Either the presentation was as crystal clear that there's no open question left, or we have no questions. I would even appreciate if you don't have a question, just say nope, no questions. That would be fine as well. A couple of feedbacks are coming in. Nice presentation. Thank you very much. Appreciate it. It's good to have you as an audience. Hope to see you at some point. You see me, I don't see you, but I would really be happy to see you at some point. Oh, here, 2 questions are coming in. But please explain the difference between BEV, so battery electrical vehicle, and electrical vehicle. And Waldy, the difference is just that in this case, the questionnaire was based on pure battery-driven electrical vehicles, or no plug-in hybrids or fuel cell electrical vehicles. At the end, it comes down that, and you might have heard this, the electrical vehicle is not a question if it will come. The answer is there. Electrical vehicles will take over, but there is still the open question of what might be the power source. Is it a battery? Will it be a fuel cell? Will it, whatever it might be? And there we differentiate between the pure battery electrical vehicle and all the other kind of electrical vehicles. Can you say somewhat more about the EMC filters? Okay, the question is kind of generic. I'm guessing it gets down to the EMC filters we are working in. I mean, in the inverter, you have quite some big EMC filters because of the high voltage and current peaks and what we need to fulfill. And here, actually, our biggest challenge is to keep the isolation. Okay. Just going through the chat.
Hey, Oliver. Well, thank you for your input in your presentation. But I see the audience liked your presentation. I also want to thank Niels for joining us and helping us with the chat. Well, I really liked your presentation. Was very interesting. You also you already received a little present from us. I heard from you, so now you have quite a lot of time to enjoy the present. Well, to the audience, I want to thank you for your participation in the events. Over the last 3 days, we had about 500 viewers over 16 sessions. So this means the end of the event. I hope next year we can have a physical event in one of the exhibition halls. I wish you the best for the coming season, and thank you for participating. Goodbye.